In this screencast, we'll continue our program design from the previous screencast. The next step is to design a function that will read the information from the CSV file and store it as data in our program. If I scroll down, I can see that I have this function as part of the template. So I'm going to uncomment the pieces that I need to work with. Designing this function is a very important change to the way we've been working so far this term. Previously, we had to type in examples for any and all data that we wanted our program to access. Now we can design a function that can read information from a file and store it as data in our program. This allows us to work with data sets that would be too large or just too tedious to enter by typing them in. As always, I'll follow the How to Design Functions recipe when designing this function. It's a new kind of function design, but our systematic design process still applies as it always does. Let's start by updating the signature. I know that the data type is called population change, not the generic consumed from the template. And the purpose should be reads information from the specified file and returns a list of population change data. Because we already have the template from the How to Design Analysis Programs recipe, I'm not going to add a body of a stub. We already have the template here. So instead, I'll go and write the examples now. I know I want to have at least 2 examples for read. And for now, I'll put empty lists as placeholders for the values that we expect. We've already looked at the file, and we saw that our file was quite long. Our file contains information from every year between 1975 and 2012. That's a lot of data if we wanted to write a test for read that would test that our function could correctly read that entire file. So instead, we're going to create 2 small test files to use in our examples. The way I like to do that is open the file in Excel and save it with a different name, usually with the same file name, but with test1 appended to the end, and then I delete most of the information so that there's only a couple of rows left. I'll do this twice. I'll create one test file that contains the information for 1975 and 1976, and another test file that contains the information for the years 2010, 2011, and 2012. I'd like to run my examples, but I know if I run them with the function in this state, I'll get some errors because it's still referring to the type consumed, which we know doesn't exist. Instead, I'll finish my function design and then run my examples. We don't have a note here about where the template is from, so I'll write template from the How to Design Analysis Program template. Let's finish the implementation of this function. First, I need to update the accumulator type. I know that I want this accumulator to store a list of population change data. And I'm going to update the name of the accumulator as well. If I'm following the convention of LO for list of, and then the letters for the name of the data type, this should be called LOPC. So I'll update that every place we use it. I know that my file has 3 header rows. I happen to remember that, but if you don't remember, you can always go check. So I need to skip 3 lines. I'll update the comments so readers know why there's more than one call to next. This won't always be the case as it's most common to have 1 header row. Now I need to create an individual data point. I'll get rid of this comment that's from the template, and I need to create a population change data for that particular year. We'll call it PC. Each population change corresponds to 1 row in the file or 1 year. So I need to figure out where each piece of the compound data comes from. I'll take a look at the file and count the rows, remembering to start counting at 0. So 1, 2, 3, 4, 5, 6, 7, 8. So I also need column 8 for the population change, and column 9 for the total population on July 1st. I need row 0, 8, and 9. I know that the CSV reader will give me each piece of data as a string, but I remember that I want these to be stored as ints. If you forget what kind of data you're using, this is a good time to go back to the data definitions and check. So I need to use parse int for each of these. I'll call parse int and give it the string that the CSV reader returns, and it will give me back an integer, which is what I need to create a population change. Let's run and see if our tests are running. Oh, I have invalid syntax, which is probably a missing parenthesis up here. It is. Let me run again, and I accidentally uncommented that, so let's give it one more try. Now there's an error that says it can't find the file, and when I look at the tests, I notice that I used the wrong file name. I called it population change test 1. And now I've made a typo. It should be parse int, not parse row. This time I didn't get any errors, but it wasn't telling me if my test passed. And I see that I did an uncomment summary, and that's what shows me if my test passed. So now, finally, after fixing those errors, I can see that I have 2 of 2 tests passing.